back. So last time when we left off 15 minutes ago, we tried to match apples and not pineapples. And we did so successfully using our own little regular expression script. So now let's move on. So I mentioned this briefly in one sentence in the last lecture, in the last hour. There is something called flags, which allows you to manipulate how regular expression is supposed to be done. One of them, the one that I mentioned last time, was the ignore case version, which basically said that I don't really care about the difference between a capitalized letter and a lowercase letter. So if there is obviously an equivalent. I'm going to list all of them on the next slide. But on this slide, I'm going to do the one that you're probably going to need to be working on. And that's the multi-line type of flag. So by default, regular expression will say that the beginning of the line is the beginning of the string, always. And the end of the line is the end of the string. It doesn't matter if you have continuation character. That means if you look at the search text, if you begin at apples, oranges, comma, and, that's not the full line. That's the beginning of the line. And the continuation of the line, which includes line, kind of new line character, and then pineapple is part of that same line. Which means, well, let's go down to line 9. And then do like this. Well, actually, you can't really do, what happened there? Right? So if you look at my regular expression, I say, start with an R, because it's a regular expression that I want to match. I say hat, which means, if you remember, beginning of the line. I say /W, which means a word character. That means any type of alphabet letter or any type of number. And then I say plus, which means, seriously, we have skipped so much. We haven't talked about the numbering. Why has that not come up? And if it's not come up, then let's do it from the normal slides, since they're clearly missing. Something went wrong. So give me 2 seconds. We did the egg, we did the spam, we did the R prefix, and then we did the special characters. We did the special characters. Right. Actually, we haven't gotten there yet. Okay, never mind. This is an example. Never mind. So the plus character is not something you've learned yet. That will come on the next slide. So let's just jump there and we'll go back. So far, we have looked at special characters as a single character. And the single character might only have one representation. There has to be one of them. Now, if you're familiar with wildcard system in Unix, if you put a star, that means that it can be any character, like the dot, but it also allows you to say how many of them there should be, or let the machine decide how many of them there should be. There could be 0, there could be many. So the first operator that I'm going to teach you, and for some reason, something is kind of glitching in the kind of machine here, but never mind. I'm going to introduce to you the maybe character. So if you put a question mark behind any type of character class char, so let's say you put it behind a letter, then that letter may or may not be there. That's basically what you're telling the regex engine. So in the case of the regular expression line that you see on line 13, I say that I want to match the letters A, then E, then G, and then S, maybe. And that's why I kind of call it the maybe kind of operator, simply because the regular expression that I want to match should be EGG or EGGS. So I allow it not to be there. So if you see the search string, we have one egg, it should match that. Many eggs, it should match that. And many eggs, which it should match only the first part of it. The ES at the end of the S, ES at the end of the line should not be matched. Whoop. I have some changes here. There we go. Running code. And then it match egg, eggs, and eggs. Because I allowed it to have an extra character, but not more than that. So that means we are in, it's really lagging here. There we go. And we're back. So here are what I call the quantifiers, a list of all the different modifications to your characters that allows you to define how many of them there are. So the first one I defined was the maybe character. It's kind of defined by a question mark, and it represents 0 or 1. Now, there are the other ones that you're probably going to be using is the star and the plus. The star is 0 or more, which coincidentally matches with how things are done in Linux and Mac on your terminal line. Star also there means 0 or more, though that one also kind of misses what character it should match. So when you say star in Unix, that is basically the same thing as a dot star in regular expression, for those of you who are familiar with the Unix syntax style. The plus is the same thing, just that requires that there is at least one match. So if you wanted to have that one match, then you should add a plus. Just like with the character classes, modifiers or quantifiers can be customly designed. So you can design, it's like, hey, I want the letter 4, but I want the letter 4 exactly 7 times. Then you can define your own quantifier by using curly braces. You start with the curly braces, and then you say 7, and then you end curly braces. That means that you will not accept 6. The question is, will you match 8? And the answer to that question is, well, yes, you will match 8, simply because 7 characters in a row do actually match in a kind of string of letters that are 8 strings long, right? 8 characters long. So now that we have that, we can kind of please ignore my error of having these in the wrong order. Here's the example, 3 slides ahead. And then you see that it starts with the hat /w and the plus. Now the regular expression should make a little more sense at least. So the hat, as we had last session, means the beginning of the line. The /w means that's a word character. And the plus means that we should have one of them or maybe more. And now let's return to that second topic of multi-line flag. If we run this code without adding a flag, then it will match only apples. But if we run it again and add the flag with multi-line, then it should match both apples and pineapples, as you can see. So it prints out 2 things from line 15, search results, where we did not add the flags, and I'm going to show you where the flag is. It's here as an optional kind of keyword argument that you add to your command. That one works both on find all and on substitution. So if you're going to use multi-line, which you're definitely going to be using, actually as a default, that's definitely going to pop up. In any work that you're doing, you're probably going to work on something that's multi-line. So remember, add the flag M to make sure that, hey, each kind of case return means that it's a new line. Though obviously there might be cases where that's not what you're trying to do and try to match it more correctly. Does that make sense? Cool. Apologize for this kind of wrong order. It would have made a lot more sense if this came after we understood what the plus sign was. Anyway, we're back. The different quantifiers. A simpler example of just using the quantifiers, since this is something you should use a little more kind of time. So here we have 3 words, no, no, and no, or something like that, taking from the great movie Star Wars, or not, depending on who you ask. And if we try to do a search for the word N-O, then it matches the first one, and it matches the second one, and it matches the third one, obviously. But it matches another one as well. But if you want to try to grab it and try to find all results, you need the plus sign to match all of the O's. So if I remove this, the plus sign, it still matches the 3 words, but it doesn't catch all the O's. And obviously, that line in that movie will make a lot less sense if it's just no, no, no. Which is kind of the whole difference. Only, undo. A little more complicated. Well, not more complicated. Trying to combine them in a sense. So we have our character classes and we have our quantifiers, and obviously they fit together. It's kind of like Lego, like most programming languages are. You have one concept, you have a second concept, you can add them together. So in the example in the previous slide, the O character is the one that I decided how many of them we should try to capture. But in this case, I say that I don't really care what that character should be. I just want it to be any type of word characters. So when I write /W star, that means that I want any word characters, but there might be 0 of them, or there might be 1 of them, or there might be more of them. So 0 or more. So for our search string, 1 egg, many eggs, all the eggs. In our kind of previous time we went to that example, we matches the first and the second. We did match the third one, but we didn't match the full word, so we didn't actually extract what it actually said. But now, when we add that star, W star, any word that starts with egg is matched. Egg, eggs, and eggs, for whatever word that is. Okay? Now, let's talk about some caveats where things get a little bit ugly. So here we have an example of word that includes apple a lot. Pineapple, apple, teenies, no, apple, pineapple. So pineapple, apple, pineapple. And let's try to match any word characters, 0 or more, and whatever ends with apple. Now, from kind of intuitive point of view, what would this match? Well, we have the word pineapple, so it would match that. And it would match the word apple simply because there's a star there that says 0 or more. So in effect, we would think that apple would then be matched as a character and kind of something to be grabbed as well. And lastly, we have pineapple. That will match as well, since everything ends with an apple. But if you run the code, it does not. It matched the whole string. And here comes kind of into the more of the refined logic of how regular expression works. Regular expression, by default, is what we would call a greedy language or a greedy search. That means that if you give the regular expression option to choose between what it can match, it will try to match as much as possible for its first search. Well, obviously, if you have multiple search, then the first search is the one that gets prioritized. So what happened in this case? Well, it tries to find for any word that starts with apple. And since that's one big word, it will match pineapple, apple, pine as that word, which then ends with an apple. So only the word that it matched perfectly. It does follow the rules that you gave it, but it's not exactly what we wanted. It might be what you wanted, but for this example, I was thinking that, hey, why not try to match for the words that are contained in them? So you could try to say that, hey, we want to do boundary characters, but we don't have actually boundary in this one. We just try to kind of extract as many apples or pineapples that we can find in a type of word. And there's a way of doing that. And that's what we call the non-greedy. And here we have some artifacts again, the non-greedy modifiers. So you remember the question mark that we learned as a quantifier? The quantifier question mark means 0 or 1. but that is only if you place it after a character class. If, however, you place it after any type of quantifier, it tells that that quantifier should be non-greedy. So in this case, if you have a plus sign and you put a question mark after it, it says that you want to match one or more, but you want it to match as least as possible. The default, when it's greedy, is will try to match as much as possible. If you need something in between, you have a problem, but that won't be helped by this type of operator. But it's really nice that in a lot of cases, when you try to kind of grab too much and make regular expression that is just simply too wide, because what you're trying to match against is a little bit problematic to actually write the code for, you can actually get away as a shortcut by just saying, I want the the matcher to be non-greedy, and it usually helps a lot. So, and obviously you can put the question mark behind any type of quantifier, the ones that are pre-built or the one you build yourself. So you put a question mark behind well, that last line is wrong. That should be a quantifier, obviously. So this should be curly braces. I should fix that before we kind of update that to the slides. Anyway, ignore that part simply because it's wrong, but you understand the point. You can create your own quantifier, and you can put a question mark behind it, and obviously that will be non-greedy as well. Okay, back to our little example. We're trying to match pineapple, we're trying to match apple, and we are trying to match pineapple again. We're using the exact same regular expression term as we did before. You can see it in line 9. We're not making any changes to it, but we're doing it again. This time, we're adding the question mark. We're saying here, /W, I want to match any word character. Star, I want to match 0 or 1 of them. But if it has a choice, it should match as least as possible. And we run the code. And here you see, it split up the words. Anything that ends with an apple is then extracted out properly, allowing you to kind of do the nuance of trying to match what you're actually looking for in this case, which was anything that ends with an apple, which is nice. Giving you a little bit of details tool to do your work. And you're going to start working on this on your next assignment. Okay. Things get a little more complicated as we work on. We take step by step. We've gone through character classes, both the standard library and the ones you can construct yourself. We have gone through the operators, as in the quantifiers and the modifiers. Now we're going to do something that's kind of a little more complicated. So that's kind of these parentheses. And it's not complicated on this slide, but it gets complicated simply because the parentheses, they have different meaning in different contexts. And it actually has different meaning in the same context as well. And there are 3 of them that we're going to go through, and there actually are a couple of more, but that's the only ones that you need to know. So bear with me when we go through all the different meanings of what to use parentheses for. So the first one that we're going to do is we're going to do extractions. Extraction, in a sense, works that simply put, extraction is that you're only interested in part of the result you're looking at. So in this case, we have the word prefix, infix, postfix, quickfix, and fix. Now, we want to know what the prefix of those words are, and we're not really interested in the word fix in this case for this really dumb example. The real examples that we're going to talk about next week, then we're going to see why these type of kind of extraction features is very, very important. But yes, if we run that code, basically what I'm saying is that the find all kind of searcher will discard anything that is not inside the parentheses. And so it is. It matches with prefix and infix and postfix and quickfix and fix. but it doesn't return the fix because we put parentheses around the /w star. Also note that, a little bit of a caveat there, the last word, the fix, doesn't have a prefix. Now, the star operator tells us that that's fine. We can expect it to be 0 because we asked the system to make it 0. And the regular expression then finds a match that said, hey, that's correct. But the content of the parentheses is nothing. There is no characters in between the parentheses. That's fine. So what does this do? Well, it returns an empty string, which we cannot see. Well, you can see it there underneath the 3 over there because of all my artifacts on the screen right now. But you couldn't actually do this. There we go. There you see it. The empty string that's getting returned. So keep that in mind. Oop. I think it died. That's nice. I have to do it again. I apologize. My editor crashed. How often is that's actually happened to me a couple of times before. It's my Apple laptop. It really drives me insane. And, so, okay, we're back. We did the group 1. So we did an extraction, and it discarded everything that was not in a group. So the question is that, can we do it multiple times, as in do multiple extractions? So here we have an example of that. We do a prefix and a postfix, or fix post, simply because we needed a postfix. And from a personal point of view, I think it's weird that the post in postfix is not a postfix, but that's just me. So we'll grab something that is before the fix or after the fix. And what it does, it returns a list, but instead of returning a string, it now returns a tuple of strings. So you have to keep in mind that the number of kind of parentheses you send into your regular expression actually change the format of how you get the result back. So it will kind of reduce it down to the simplest way of doing it. And if you say, hey, I want to match kind of this type of string for one group, then it will return that string. But if you say I want 2, then simply you cannot return things as a string because it's too much information. So what it does, it creates these tuples. And obviously, if there's 0 characters in those tuples, they will be empty. So from these tuples, you can read that that's the prefix. And from the second one, you can read that's the fix post. Very straightforward. So you have to kind of keep that in mind. When you go above 1, it changes behavior. Moving on. Now, second way of using the parentheses. So we did the extraction. That's what you know so far. Now, when we get to use the groups in substitution, we can use something that is called, let me call it here, we can do back referencing, to reference back. So if you look at the same thing that we have always done and see the parentheses, you say /w star. The W star now refers to any word characters, 0 or more, and we want to grab that part of it, and I want it to end on a fix. But look at the next slide, the regular expression out. So far, we've done substitution. We have just substituted in standard words. We've added and replaced apples with oranges. But here, I've added a regular expression on what I'm going to replace it back with. You have to keep that in mind, that regular expression substitution does regular expression both on input and output. So you get a little more of an advanced feature. And what I use as a command is a /1. And the 1 refer to the group that we created. So if I have a set of parentheses, and start referring back to it, then I need a /1 to refer back to my group. So in this case, when I say /w star as a group fix, then I'm replacing the fix with a break, which should be sensible word-wise. Yep, a pre-break well, that's not a word, but in break, post break, quick break, and a break. So exactly the same as the source text, but replaced with the actual prefix is retained. There are other ways of doing this, obviously. You could have just replaced fix with break directly, which would be simpler. But as the, kind of your examples becomes more and more complicated, obviously that won't be an option anymore. It doesn't need to have very high complexity before this is the way to do it. You need to do back referencing to do the proper substitutions. So that's the second type of way of using parentheses. Another way, well, this is the same way, just a more advanced way of using the second way of doing it. I use /1 to refer to back referencing to my group, but that's because I had only one group. Obviously, you can have multiple group, and the rule of thumb is simply put by kind of how many numbers there are in the kind of the decimal system. You can have up to 9 references back. So /1 will refer to the first one, and /2 represents the second one. So in this case, I'm saying I want to grab funny and bunny, and I want to swap them around and say that I want to have bunny funny. Does everybody see that that's the case here? Since /1 refers to funny and /2 represent bunny, they get swapped. And that's what we get. Hello, bunny funny. Which is nice. And you can do these type of advanced substitutions, which is, you can think of it, though, that your guys are not sitting with these type of strings every day. Your guys are sitting with code. And sometimes you get into the situation where you're going to do a little bit of refactoring. Not a big one, but perhaps you need to change a variable name. Maybe you need to kind of redefine how a function is set up and type of things. These type of tools is something that I use every single day in my basic work through my editor, through Vim. It's really nice to be able to do kind of advanced substitution on the fly. Yeah, we're going to have examples of that at some point next week. But for now, we're going to just play around with the really, really dumb, stupid, tiny examples, just so you can understand what's going on step by step. Okay? So when you build up really, really complicated regular expressions, that might be the case for your assignment. That depends on how you break down the problem and how often you call the regular expression engine. But as a rule of thumb, when things get complicated, you might want to sort things out. So remember that you want to be able to, well, first and foremost, here I'm doing 2 things. So we're getting back to the complexity of what the parentheses are. You can tell regular expression that I do not want to grab a group by adding the first 2 characters in your parenthesis kind of content as question mark, colon. So typically anything, as in there's an operator and then colon, is typically how you tell regular expression to do advanced stuff. And you don't really need to do a lot of them, but the non-capturing group is something that you kind of need. So the non-capturing group in this case is that, hey, I want to grab first any word characters, 0 or more, maybe, so as least as possible. Then I want to grab the kind of the ha, and I want to have 0 or more of them. And then I want to grab word characters, 0 or more, maybe, as in it's many types that I want. So from the source text, you kind of see what the logic here is. The first part is the mo is going to getting grabbed by the first group. And the last one, the W star question mark at the end, is going to match the ho. And all the ha's in the middle is going to be matched by the non-capturing group. Did everybody understand that? Let's run it. And as you see, I did a replacement, and it matched 2 and 1, and then we get mo he. Is that correct? Something kind of seems weird with that. Huh?
Shouldn't it be reversed?
Yeah, shouldn't it be reversed? That's weird. How did that not work? I'm getting curious. So R1, R2.
On the Feinberg example, you have a space between the 1 and the slash.
Yeah, but that doesn't really matter.
Doesn't the 2 reference the non-capturing?
The non-capturing the ha?
Yeah. Try 1 and 3.
That might be true. I don't think so, but let's try. Yeah, invalid. It only references to. This might be a bug on my system, not your system. So this is really annoying. This is weird. I have to think about this. I might have a solution for you to the next week. But right now, we're going to need to move on. Now, a little bit of a detail that I did not talk about in this slide that is worth noting, that I put a quantifier after a group. So instead of just saying I want this character and I want multiple of them, I want the whole group to be multiplied. That's how I can match the H and the A in ha 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 multiple times. And that's really nice things to do. So another way of using the parenthesis, and it's not doing extraction, is that you can group them together to do multiple quantification. As in putting a question mark after it or a star after it to say that, hey, I want this many of this whole group as a whole. And then we'll have to match the whole H and A to do so. Very curious about that one. Then we get to the last way of using the parenthesis. So we've done the extraction. We can tell it not to do the extraction. We have the substitution, and we did the kind of put them as a group and put the modifier, no, the quantifier at the end. The last one is that, well, you know the character class when you say A, B, and C. There's another way of doing it. You can make, and let's do this live. You can do the same thing by saying I want a group and I want A, or, nope, that's the wrong button, B or C. That will be equivalent to doing A, B, C. Does that make sense? So basically what the group is doing when you add the pipe character or the or character or whatever you call it is that I want A or I want B or I want C. Now obviously that syntax becomes a little tedious, so using a kind of character class for doing the same things makes a lot more sense for an example like that. But when you do multiple characters in each option, then it makes a lot more sense. Because then it says, hey, I want to match the word egg, or I want to match the word spam, or I want to match the word ham. So they can be multiple characters long. And they don't need to be the same length. You see that kind of the first and the third one are 3 characters long, while the second one is 4. So and obviously you can also put in kind of quantifiers and modifiers and all that stuff inside the parentheses. Now, I'm not that interested in grabbing this group, so I added a question mark colon to it, non-capturing. So as a rule of thumb, if you're not going to use it, put question mark colon. That means that anybody is going to read your code after you, understand as like, okay, I did not try to actually capture this group. I tried to do something else. So it's a kind of good rule of thumb to always add the question mark colon for the groups that you're not going to use the content for. It's not that complicated to change it back if you actually do need the content at some later point. Right? We can run this. We will match any word characters, 0 or more. That starts with either egg, spam, or ham. And that we do match. We match the egg. Doesn't have a postfix, but it doesn't matter because we can match 0. It matches the spams with the S at the end because, hey, we are allowed to match more characters after the spam. And we're matching the hamses, which is still not a word, which is a common theme amongst my slides. I don't like English, apparently. Anyway, Now, bringing it all together. We can do a lot of these things at the same time. And so far, we did first the capturing group. So let's go through this really slowly here. We did the capturing group in the sense that we did extraction from the search text and then back again to what we want to replace it with. But it doesn't really necessarily need to be that way. A capture group can be inserted into the search field. So if we try to do the prefix and the prefix, perhaps we want to get the word repeating. So in this case, we're searching for either pre or post. That's fine. We add kind of a bar between them. And then we do a back reference, a slash number, to say that, hey, I want to have it repeating twice. Now, here's a kind of a caveat with these type of things. I said /2. In a sense, we only have one completed capture group. Shouldn't it be /1? And the answer to that question is that back references always refer to the beginning of the parenthesis, which means that, hey, we have another group, which is this group. That's the first group. This is the second group. So when I say /2, that means that I'm matching either pre or post twice. And keep in mind, this is kind of a small kind of quirk in this type of things. It has to be the same thing. That means that this will match pre-pre, it will match post-post, but it won't match pre-post or post-pre, typically. This is a dialect question, but as a rule of thumb, it will not. Now, if I say that I might have that, I add a question mark. That means I won't have 0 or more of it. That means that instead of just matching the pre-pre and the post-post, I also allow to match for prefix and quick fix and fix. Well, actually, I will not match fix. Why is that? Because I'm requiring at least one of them. You see that? Because I didn't have a question mark behind this one, but only this one. Then I'm forcing it to be at least one, because the original group will still be there. When I've kind of searched out each of these words, which is the first through the fourth, but not the fifth, I replace it with the context that I grabbed, which is not the /2, but the /1. So you see that kind of using this nestedness, that it's like, okay, I'm going to do something in the middle here, and then I'm going to grab a bigger part, and then I'm going to extract that as well. And then I add break instead of fix. So basically the same thing as we did last time, but now we're only grabbing word 1 through 4. Because, hey, we're going to see it in action. So that's our examples. So you see, you get the pre-break, the pre-pre-break, the post-post break, the quick fix, and the fix. Obviously, something is wrong. My God, how does this happen? Anyway, any ideas?
It doesn't match pre or post?
It doesn't match a pre or post. Nope, it doesn't. It really doesn't. How? Yeah, God, this does not happen that often to me.
Quick, right? So it shouldn't match.
It shouldn't match.
Why?
I don't know. So, forcing it. Oh, no, this is completely natural. So, do you guys see what just happened here? This is not a search result. This is a replace question. My mistake here. So, we're replacing any fix with break. And obviously, this one will not match with this fix. And indeed, it doesn't. Fix is left by itself. And the same thing with quick fix. Quick fix is not matched because there is no prefix pre or post. If I, however, added another option here and say, what's the word? Quick. Like that. Then we would expect that the quick fix should be replaced with a quick break. And it does. So this one works as it's supposed to be doing. Cool. I'm not completely useless with my slides, which is really nice to know sometimes. Okay, before we kind of complete today's session, let's go back to the first example, the first really messy example, and see what was going on there. First time, it didn't really make sense, but now it should make a little more sense, hopefully. Step by step, we're trying to match lines one by one, and I'm doing a little bit of tweaking here. And this is how typically I use a regular expression when I'm going to do advanced type of substitutions. I make a little bit of trick, and I'm going to show you what that trick is. So, first of all, the search string. I'm interested in grabbing the search string in the sense that I want to substitute it. I don't really need to do the grabbing because it matches everything when it's not actually grabbing, but I had it there just to show you what is going on. Obviously, this character here makes a lot of sense. What we're trying to match should be at the start of the line. So we anchor it to the left side of each line. Obviously, we added a flag re.m, which means that, hey, this should be multi-line. That means that each line should have the regular expression should start over at each line, meaning that we're not going to match more than just kind of at the beginning here, but also beginning here, 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 and here. Then let's look at what we're trying to match. So I'm being a little more explicit here in the sense that, okay, I'm going to match a date, 1.1.1950, which is start of epoch, as in Unix time. But the problem is that I don't really know how that format is going to be explicitly, or I could kind of try to get all the different way of that formatting. So, for example, that one in the beginning might be 2 characters. The same for this character. It might also be 2 characters, simply because that's how dates are written. So I just simplify it down. And I say that I'm making a special character class. I'm saying that character class should cover 0 through 9. And it should also include the character dot. Remember, the dot is a special character, which means any character except when it's inside a character class, which is a literal. So the commands are different if you're inside a character class compared to if you're outside of it. Okay, and then I say I want one or more of it. And that should grab the whole date, from the first to the 0. Then I'm trying to grab the timestamp, and I'm doing the same thing again, but instead of a dot, I'm looking for a colon. So that little kind of part here should match the timestamp. Keep in mind that I have a literal space between them to say, hey, space are literals, so I can match that as well. And then it's a reference to what modules you're in and what function that called when you did. This is typical logging that says, okay, something happened, I'm printing it out, this is where it happened. So this is standard advanced type of logging formatting. So instead of trying to figure out what that should be, I'm just saying, hey, I want it to be a word character, then I want a dot, and then another set of word characters, and then ending with a colon. So in a sense that I should maybe be a little more careful with my W's plus here, in the sense that it's very greedy. You can match something outside of the scope of what I'm looking for, but because you have a context of how big the regular expression should be, then that shouldn't be a problem. Also, I'm specifically saying, hey, we need the colon there, which also is part of that. Last little bit. I'm doing a replacement, /1. That makes perfect sense, hopefully, that we're replacing it with the same line that we put it into, everything inside the parenthesis. But I'm adding a literal @ sign there. So you shouldn't think that that is a command of any kind. That's actually a literal @ sign. And why would I do that? Well, remember, we're looking at statements that are multi-lined in a sense. And a return character or a new line character does not represent that we're going to the next expression. So I'm inserting a special character, the @ sign here, to indicate that I want to split up my text in such a way that when I'm going to print out line by line, the @ character is what I'm splitting on instead of the new line character, because that's pretty much in use. And typically, it might not be the @ character. It might be any character that you like, just anything that's not in the text. And you will find something like that. And that allows me to do a line-by-line printout. I just need to split on the act character, is the one that I inserted, instead of all that logging text that I tried to match for, which allows me to do this. And there we have this kind of solution to how I did that example in the beginning of the lecture. Okay, thank you for today, and I'll see you back here next week. Any questions before? No.
What if you have a line that does not start with an error? Wouldn't this code change that line?
No. Well,
Since you're just swapping.
it starts with an error.